Hey guys, Dev Party here, and today we're going to be making our own standard C++ library because why not? Now, the first thing we're going to want to do is make sure you have your own project open, make sure you have the main C++ file inside your search file, and you got all that, we're good to go. Now, today we're going to work on memory allocation like malloc and realloc in C or C++, because that's kind of the basis for a lot of data structures that you're going to be seeing in this standard library that we're going to make over the course of the next few episodes or whatever. Now, the first thing we're going to do is we're going to add a new folder called n_std for new standard library, and we're going to add a new item called n_std.h. Now, we're not going to put anything in this yet, but we're also going to include it in here /nstd/nstd.h, and that includes our new standard library. Now, like I said, we're going to get started on memory, so let's go ahead and make another item called memory.h, and we're going to go ahead and include that in our new standard library. Include memory.h. Boom. Now, the first thing we're going to do is we're going to think about what do we want this namespace to be called. Obviously, it's going to be nstd, like we've been doing. We need it in a namespace, and the reason we want this is so we don't interfere with anything that the developer might be using, and everything that they need is inside this one namespace. So first, we're going to work on our memory allocation function, just bare bones memory allocation, and this is going to be a void pointer function, because we're going to turn a void pointer to the memory block that they want, and we're just going to call this allocate. And we're gonna we're gonna have one parameter. It's gonna be an unsigned long, so, and that's gonna be size. And the reason we're not using something like size t here is because a size t is part of the standard library, and it just would not really work. It's showing up here, but we can't really use it. So unsigned long, and that's what we're gonna use. Now, this gives us our size in bytes, and you're not really able to do void pointer like data or something equals new void size. That's not going to work. As you can see, it's going to, array type of void is not allowed. So what we're going to have to do is we're going to make a char pointer memory equals new char by size. Now, the reason we're using a char and not something else like a integer or long is because a char is exactly 1 byte, and that'll translate perfectly with the size parameter that we have up here. Now, a char pointer is not a void pointer, obviously, so we're going to have to return something other than memory. Or you could just return memory, but what we're going to do is we're going to do a void pointer to memory to make it very clear that we're not returning a char pointer, we're returning a void pointer, because we want them to be able to make that memory whatever they want. Now, we can go ahead and actually try this allocation function. We're going to make like a fake string up here. We're going to say like char pointer string is equal to a char pointer of nstd allocate. We're going to say 3 bytes. Now, we want it to be 3 bytes because we're going to write hi in there. But you might be thinking to yourself, well, hi is only 2 letters. It's hi. Why did you need 3 letters to store 2? Now, the reason that is because all strings in C and C++ are null terminating, which means that the last character in them is going to have to be this, null, or null pointer, or the null terminating character, which, let me go find out what that is real quick, because null is also defined in standard library. Alright, so the null character is \0, so that'll make sure that when we actually print this string out, it doesn't, like, keep going until it hits a null character. So we're just going to say string of 0 is equal to h, and then string of 1 is equal to I, and then string of 2 is equal to this null terminating character here. And then we'll actually be able to use this string to do whatever we want, but we don't really have anything to print to the screen yet. We can't really do that. So we're going to cheat just for a second using the C++ standard library, just for a moment, to show that our memory allocation function did indeed work. So we can print this string, and we can go ahead and see that it does indeed print hi, which means that our memory allocation function is working. Now we're going to delete this, go back to our nice, clean standard library. I'll pin that real quick. Now, allocate obviously isn't the only thing you want. You're going to want a reallocation function so that you can make a block of memory bigger. So we're going to do reallocate, and we're going to say void pointer pointer, and we're going to do unsigned long size again. And the reason we're inputting a pointer is so we can copy the data from the old pointer into the new pointer. That's kind of the entire purpose of the reallocate function. Now the first thing we're going to do is we're going to do char pointer memory, just like we did last time, equals new char of size. And then we're also going to have to make another char pointer here called char pointer maybe old memory, like so, equals a char pointer to a pointer. And this is so we can just get the data out of here, because you can't actually get data out of a void pointer. Then we're going to go for int I, not int, actually, we're going to do unsigned long I equals 0, I is less than size, I plus plus. Struggled really hard to make that for loop right there. And now we're going to go memory of I is equal to old memory of I. And you might bring up the point that our old memory might only be like this, and then our new memory might be this, and then we're going to try to pull out bytes that don't exist. Now this is actually fine because they're probably going to be overwritten anyway, and if they're not overwritten, that's kind of like, it doesn't really matter because the bytes are actually there, they're just not connected to our pointer until we make it like this. And then we're also going to return a void pointer to our memory. And that would be our entire reallocation function if we weren't thinking of memory safety. Now, obviously these functions aren't very memory safe in general, but we do want to delete our old pointers so that we don't just keep duplicating memory, and we actually want to copy over the memory and then delete it. So that'll be very useful later. So we can go ahead and try this reallocation function. Maybe we want to add an exclamation mark to our hi string to make it much more obvious that we're saying hi to someone, maybe across the room. They need to be able to hear us. So we're going to say reallocate 4, so we can just add one more reallocate string and 4, so we can add one more character. We don't have to change anything except for the second character changes to an exclamation mark, and well, that's the third character changes to an exclamation mark, and the fourth character is a null terminating character. And then we can go ahead and print out our string here, and this is going to be, oh yeah, we need to quickly cheat again. But we're going to print out our string here, and we're going to see that it's going to be hi exclamation mark, which means that it is indeed copying over the old memory and making the memory buffer bigger, which is great. That's what we wanted. Alright, so now that we have some basic memory allocation functions, we might want some other things, just like this. Maybe if we had char new str, we'd want a new string, we'd want a memory copy, like so. Maybe string into new string, like so. And obviously we don't have this function yet because it says it's undefined. So what we're going to do is we're going to put this into what I want it to look like in a second. And we're going to go ahead and define this memory copy function up in our memory.h. So we're going to go void pointer memory copy void old pointer void new pointer and unsigned long size, because you can't get the size of a pointer array from nothing. So we're going to go ahead and take a look at this memory copy function and think about what it does. Obviously, we just want to copy the old memory into the new memory and do nothing else. So we're just going to go for unsigned long I equals 0, I is less than size, I plus plus. We're going to say new pointer of I is equal to old pointer of I. Now you might see the problem here that our new string is just memory copying blank, and I just realized this as well, so we actually do need to say allocate first, just for like so, and then we can go nstd memory copy like so. Just realize that, so we want to copy string into new string with 4 bytes. Boom. That's a little bit of a bug that I'm happy I noticed there. Anyway, so new pointer of I is equal to old pointer of I. But these are void pointers that we're passing in. So again, we're going to need to do char c, maybe like char old pointer is equal to char pointer to old pointer. A lot of pointers going on. And char new pointer is equal to char pointer to new pointer. And then that allows us to go ahead and just copy the data over. I keep trying to do int unsigned long I is equal to 0, I is less than size I plus plus. And then we're going to do char new pointer of I is equal to char old pointer of I. And that is the entire function, actually. Also, we want to return, just in case they want to get that value out. So we're going to have to do a void pointer to char new pointer. And that'll just go ahead and memory copy. So we're going to cheat one last time for this episode. And we're going to go stdcute new string. So we can go ahead and make sure that this is working. Hashtag include IO stream. Boom, and we're going to go and check that our memory copy function is indeed working, and as you can see, it did print high again. So those are just the basic memory functions that we're going to need to make our standard library in C++, and I think that's actually all we're going to do today. This is a pretty good amount of memory functions. This is basically all we're going to need to make like vectors and hash maps and all that. So if you guys like this episode, please leave a like and subscribe, and I'll see you all in the next episode. Bye.